Hello, I'm Ardra. So in today's class, we are going to discuss about each and every question of the CUET 2022 question paper. So we will discuss about what are the type of the questions, and we'll be discussing about each and every question and what will be our approach to every question. So without any delay, we can go to our class. First question: according to Slater's rule, the effective nuclear charge Z effective for a 2p electron of the carbon is. So we want to find the effective nuclear charge of the 2p electron of the carbon, and this is done using the Slater's rule. And using the Slater's rule, we can find the shielding effect, and minusing the atomic charge, minusing the shielding constant with the atomic charge, we can get the effective nuclear charge of the 2p electron, and every electrons in every shell. In this question, they said we have to find the effective nuclear charge of the 2p electron. And the option given here is A 2.75, B 3.25, C 4.00, and D 6. So when we go to this question, first, we want to see the electronic configuration of the carbon, that is 1s2, 2s2, and 2p2. And here we want to find the effective nuclear charge of the 2p electron. So using Slater's rule, this is the equation, that is Z effective is equal to atomic charge, that is Z minus atomic number, that is Z minus shielding constant. So first we want to find the shielding constant. According to Slater's rule, when we group the atomic orbital, here we can group the atomic orbital into one group will be 1s, and the second group will be 2s and 2p. So in the first group, the electron containing this in the same group, we have to multiply the number of electron in the same group with 0.35, and in the next group, that is near to the group of the group of the electron of our interest, we want to multiply the number of electron in that group into 0.85. So when we do the calculation here, in the same group there is there is 3 electrons other than 1 electron under our interest. So there will be 3 into 0.35, and in the second group there is 2 electron, that is in the 1s. So we have to multiply 2 into 0.85. So when we add this, we will get shielding constant is equal to 2.75. But in the question, it is asked that we want to find the effective nuclear charge. So we want to minus this 2.75 with the total atomic number, that is 6. 6 is the atomic number of carbon. So Z effective is equal to 6 minus 2.75. So our answer will be 3.25. In some cases, when we get this answer, that is shielding constant is equal to 2.75, some students will run into write that is the answer, but we have to minus that value with the atomic number of the atom of interest. So when we minus that, we will get the answer as 3.75, and our answer will be the B option, that is 3.25. Next question: according to Lewis structure of NH, how many sigma bonds, pi bonds, and lone pairs of electrons are present? So we have studied about the Lewis structure. We want to find the number of pi bonds, sigma bonds, and lone pair of electron in the chemical compound, that is NH. So first option, sigma bonds 2, pi bonds 2, lone pair electrons 2. And second option, sigma bonds 3, pi bonds 2, lone pair 0. And C option, sigma bonds 3, pi bonds 1, lone pair 2. And third and fourth option, sigma bonds 3, pi bonds 0, and lone pair 4. So when we draw the structure of this molecule, that is NH, there will be a double bond between the nitrogen, and each hydrogen will be connected to the each nitrogen. And in the nitrogen, we know that there will be a lone pair also present for the nitrogen. So when we count the number of sigma bonds, that is one sigma bond is between one nitrogen and hydrogen, and one sigma bond will be between one nitrogen and another nitrogen, that is one pi bond and one sigma bond will be present between these two nitrogen, and other sigma bonds is present between other nitrogen and the hydrogen. So total number of sigma bonds is 3. So we can exclude the option, that is option A, sigma bonds 2. And next we want to find the number of pi bond. The number of pi bonds will be 1. So we can easily remove other options also, and we have reached at our correct option. And the number of lone pair of electron, one lone pair for one nitrogen and one lone pair for other nitrogen. So the total lone pair of electron in nitrogens will be in this molecule will be 2. So our answer will be sigma bonds 3, pi bonds 1, and lone pair 2. So that will the C will be C will be the correct option here. So next question. Which set of elements has the lowest melting point? So there is given some of the set of metals, that is elements, that is one is alkali metals, B alkaline earth metals, and C transition metal, and D lanthanide metal. Of this, which will be the elements that have the lowest melting point? So when we approach this question, we can easily find that the alkali metals have the lowest melting point because they have only one electron in the loosely in the outermost shell. That it have low ionization energy. It is very reactive, and it will mostly form only single bonded complexes. So it can easily cut using a knife also. They are soft metals. They have low melting point. In other case, other metals can form multiple bonds, which make them very strong, and we have to spend a lot of energy in order to melt them. So alkali metals like sodium and potassium can even cut easily. So alkali metals are the lowest melting elements in the periodic metals that is given here in the option. Next question. Given below are two statements. Statement 1, hard acids form complexes with the stabilities in the order I minus less than, Br minus less than, chlorine minus less than, F minus. And statement 2, soft acids form complexes with the stabilities in the order F minus less than, Cl minus less than, Br minus less than, I minus. In the light of the above statement, choose the most appropriate answer from the options given below. And the options are both statement 1 and 2 are correct, and B statements, both statement 1 and 2 are incorrect, and C statement 1 is correct but statement 2 is incorrect, and D statement 1 is incorrect but statement 2 is correct. So when we do this question, we know that in the case of when we take the acid strength of the halogen elements, that is HF, HBr, HCl, HBr, and HI, the most strong acids are below that group. That is, HI is the most strong acid. So the conjugate base formed from that acid will be very weak. So the F minus, the HF is the lowest, the weakest acid among that group. So the conjugate base will be very strong. So F minus is a hard base. So according to a hard base and according to the hard acid principle, that is, hard acids always prefer hard base, and and soft acid always prefer soft base. So here F minus is a strong base, which is a conjugate base of the comparatively weak acid HF. So hard acids prefer hard bases. So this statement is true. That is, F minus is a strong base. So hard acids will prefer F minus to bond with F minus. And next statement is, soft acids form complexes with the stabilities in the order. So I minus is a soft base. It is a weak base. So only soft bases will prefer I minus. So soft acids form complexes with the soft bases, and it will be in the order F minus less than, Cl minus less than, Br minus less than, I minus. So both the statement 1 and 2 are correct. So our answer will be option A. Next question. It is a little complicated question, but when we know this, we can easily answer this. So the potential diagram of manganese at a concentration of H plus equal to 1 is given here. So it is an electrochemical, it is a redox formation. That is, one complex is undergoing comparative reduction. So in further steps, so MnO4 minus changes to MnO4 2 minus, and then MnO2 and Mn3 plus and Mn2 plus and Mn and ultimately Mn in the zeroth oxidation state. So we want to find what will be the value of X, Y, and Z. And the options are X equal to plus 2.46, Y equal to plus 2.82, and Z equal to 1.32. And B the option x equal to 1.23, y equal to 1.69, z equal to 1.51, and C x equal to 1.23, y equal to 2.07, z equal to 1.32, D x is equal to 1.23, y equal to 1.38, and z equal to 1.51. We want to find the answer. So here, if we want to find the value of x first, here we first want to find the oxidation state of manganese in each of this complex. In MnO4 minus, the oxidation state of manganese is +7, and in MnO4 2 minus, oxidation state is +6, and in MnO2 the oxidation state is +4, and in Mn3 plus, oxidation state will obviously 3 plus, and Mn2 plus and Mn, the oxidation state will be 0. According to equation, it is given that N3E03 is equal to N1E01 plus N2E02. So if we want to find the value of x, the change in oxidation stage from MnO2 to Mn2 plus is 2. So the N3 value will be N3 value will be 2. And here we can see here that in the first step, there is a change from MnO2 to Mn3 plus. The change in oxidation state is 1, and the change in potential is 0.95. So we can easily say that 1 into 0.95 plus, here in the second step, for the conversion of Mn3 plus to Mn2 plus, oxidation state change will be 1, and the potential here used is 1.51. So when we are doing this in the equation, we can calculate the value of E03 as 1 into 0.95 into 1 into 1.51 by 2 is equal to 1.23. 1.23 will be the value of x. Like that, we can calculate the value of y also. So in the case of y, here, Mn in the +7 oxidation state is turned into Mn in the +4 oxidation state. So here the N3 value will be 3. N3 value will be 3. And in the first step, for the conversion of Mn +7 to Mn +6, oxidation state change is 1. And in the second step, and the MnO4 2 minus to MnO2, the change in oxidation state is 2. So we can easily do the calculation. 1 into 0.56 for the first step plus 2 into 2.26 for the second step divided by total change in oxidation state, that is 3. So our answer will be 1.69. So y value will be 1.69. Next, if we want to find the Z, here, the oxidation change is from +7 oxidation state of manganese to +2 oxidation state. So we have to see all the steps that is converted. So if we want to find E0 value, we have to do the calculation, that is 1 into 0.56 plus 2 into 2.26 plus 1 into 0.95 plus 1 into 1.51 divided by whole change in the oxidation state, that is 5. So we will get the answer as 1.51. So when we see that, Z value will be 1.51. So x is equal to 1.23, y equal to 1.69, and Z equal to 1.51. So our correct option will be option B. Next question is, which of these characteristics describe the PCl3 molecule? PCl3 molecule, that is phosphorus trichloride molecule. First, it is a option, that is it is a trigonal planar in shape, and B, the phosphorus atom is sp3 hybridized, and C, it is all the bonds in the PCl3 molecule is polar, and D, all the bonds in PCl3 is non-polar. Which of these statements is true? So choose the correct answer from the options given below. A and B only are correct. B and C only are correct. And C, A and D only are correct. And D, B, C and D, all the 3 are correct. So when we see the structure of PCl3 by hand hybridization, we can see that in the phosphorus molecule, in the phosphorus atom, this will be the electronic configuration, and there will be no excitation of electron, and the sp3 orbitals, 1s and 3p orbitals of phosphorus will undergo hybridization in order to form hybridized orbitals. So there will be 3 lone pair of electron in 3 sp3 orbitals, and 1 lone pair will be occupied in one of the sp3 orbitals. So it is true that in phosphorus, the hybridization of phosphorus will be sp3. So the B statement is true. And in phosphorus, there will be a lone pair of electron. When the hybridization is sp3, the ideal geometry that a molecule should adopt is tetrahedral, but there is a lone pair of electron in PCl3, so it also have to accommodate in the structure. So the lone pair will occupy in the one of the sp3 orbitals. So in order to avoid repulsion between the lone pair and bond pair, this PCl bond will form a pyramidal shape, not a tetrahedral geometry, and not a trigonal planar shape. So that is wrong. That is, this molecule is trigonal planar shape, in shape. So option A is wrong, and the statement A is wrong. That is, PCl3 is trigonal planar in shape. So A is wrong, B is true. And because phosphorus and Cl have a change in the polarity, that is, Cl is more negative than phosphorus. So the bonds in PCl are polar bonds. So B and C statements are true, and D, that is non-polar molecule, that is not correct. It is not a non-polar molecule. So our option correct option will be B, that is B and C statements are correct. Next question. We have given some options here. The correct increasing order of the bond angle among F2O, Cl2O and Br2O is what? The correct order of the bond angle for this complexes of halogens are we have to see here. So here we can say that all the elements other than the central element is from halogen family. So the number of lone pair and hybridization of all the atoms are the same. And from the periodic properties, we can say that the bond angle is inversely proportional to the electronegativity of the surrounding atom. If the center atom is the same one for all the three molecules, the bond angle will be inversely proportional to the electronegativity of the surrounding atom. That is, bond angle increases on decreasing electronegativity. Here we can see that fluorine is more electronegative than chlorine and than bromine. So fluorine will have the lowest bond angle, and chlorine will have the slightly highest, and bromine will have the most bond angle in these three compounds. So the according to fluorine will have the lowest bond angle. So F2O less than Cl2O less than Br2O will be the correct answer here. Next question. The ground state, what is the ground state electronic configuration of the copper atom? So copper is in the D block of the periodic table, and copper will have a atomic number of 29. So when we draw the electronic configuration, we will get the configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 3d9 and 4s2 according to the rule. But in order for the copper to have extra stability from the full-filled d orbital, it will adopt this configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4d10 and 4s1. So that is the ground state electronic configuration of copper atom. Likewise, we also know that chromium will adopt 3d5, 4s1 configuration because of the extra stability of the half-filled d orbital. So the ground state electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. It is a direct question, and the correct option will be B. Next question. In the molecular orbital theory, there is a graph is given here. The following graph will represent a psi bonding molecular orbital, and the psi bonding is equal to psi A plus psi B, and B option psi anti-bonding orbital. It is formed by minusing psi A, that is the wave function of A minus wave function of B, and here next option is psi A and psi B for individual hydrogen atom, and psi D, this molecular orbital, is the probability function of bonding orbital. We want to see which will be the correct answer for this graph. So when we consider the bonding molecular orbital, the psi A of one atom and the psi B of another atom will combine, and there will be a joint formation, and here the probability of finding the particle will be more. That is, they will join to form a probability region. In the case of anti-bonding, both will be in opposite direction, And when they combine together, in between them, there will be a region with a zero probability of finding that particle. So this molecular orbital is not the graph of bonding and anti-bonding. And here we can see when the hydrogen atoms are combining, here we can say that both is independent of each other. And in this molecular orbital graph also, these two wave functions are independent of each other. So this graph is the psi A and psi B of two individual hydrogen atoms. So the C option is the correct answer for this question. So a reaction scheme is given here. In the reaction, 2MnO4 minus plus 16H plus 10 Br minus gives 2Mn2 plus 8H2O plus 5 Br2. Br minus is the, we want to say what is the role of Br minus here. So A option, oxidizing agent. Br minus ion is an oxidizing agent and it is oxidized. And B option, Br minus is an oxidizing agent and it is reduced. And C option, reducing Br minus is a reducing agent and it is oxidized. And D option, that is Br minus is a reducing agent and it is reduced. When we see the redox in the chapter redox reactions, we can say that an oxidizing agent is the one that is getting reduced. That is, it will have a it will have a high oxidation state, and after the reaction, if it is an oxidizing agent, it will go to lower oxidation state. And for a reducing agent, it will get oxidized. That is, it will have a lower oxidation state at the beginning of the reaction and it will go to a higher oxidation state after the reaction. So that is the definition of an oxidizing agent and a reducing agent in redox reaction. So here we can see the Mn plus is MnO4 minus in this complex compound and this ion, Mn is in the +7 oxidation state and the Br minus is in -1 oxidation state. And after the reaction, Mn will change to 2+ oxidation state and Br is changed into 0 oxidation state. That is, the oxidation state of Br increases. It will go from -1 to 0th oxidation state. So here, Br is getting oxidized. A compound that is getting oxidized is called as a reducing agent. So our correct option will be C, that is Br minus ion is a reducing agent and it is oxidized. So our option will be option C, Br minus ion is a reducing agent and it is oxidized here. Next question, for the lanthanides, a statement, so first statement is given here. First statement A is lanthanides display only the +3 oxidation state, and B, oxidation number +2 and +4 occur when they lead to noble gas configuration, and C, oxidation number +2 and +4 are observed when they lead to half-filled orbitals, and D, ytterbium 2+ has a completely filled F orbital. Choose the correct answer from the options given below. Option A only is correct. B and C statement are correct, and C and D statement are correct, and D, B, C and D statements are correct. So when we see the case of lanthanides, it is said that the lanthanides will display +2 and +3 oxidation state. It will not only be seen in the +3 oxidation state. So that statement is wrong. A statement is wrong. And oxidation number +2 and +4 occur when they lead to noble gas configuration. That is true. The mostly +1, +2 and +4 oxidation state occur when they lead to noble gas configuration because it is more stable. And if they are in noble gas configuration, the +2 and +4 oxidation state lead to half-filled orbitals. So that statement is also correct. And in the ytterbium +2, we can see the configuration will be xenon 4F14 5D0660. So we have a completely filled F orbital. So that statement is also true. So our correct option will be B, C and D only. That is B, C and D options are correct here.